All right, folks. So this is the very first YouTube lecture that you're going to be watching, and this is focused on section 1.1.1 from your textbook. And this lecture is going to be titled Safety Culture. All right, so we're going to talk a little bit about safety and a little bit about the culture that's associated with safety and kind of give you the basics, the foundations basically is what we're after here. So the very first thing that I would like for you to kind of relate to is a hot stove eye. So when you were little, as a baby, you did not know what a hot stove eye was, right? And there could have been a possibility that a hot stove eye was on, and maybe at some point in your childhood, you went over to the hot stove eye and accidentally, or purposely for some of us, put your hand on the hot stove eye. And you probably went, ouch, right? Well, those are the types of things that we're going to be talking about in this lab, because as a lab employee, you are a newborn baby, right? You have no clue what is safe and what's not. You have no clue the consequences of you doing something that isn't necessarily safe. But once you do them, you completely understand the no-nos associated with those types of things, right? So after you put your hand on a hot stove eye, I guarantee you that unless you're a crazy person, you probably would not want to put your hand on a hot stove eye again. Well, there's a problem here. If you were in the lab, well, hopefully you won't ever put your hand on the stove eye in the first place, especially if the company and we do our job the proper way. We do not want something bad like this to happen. You can learn from these things a different way. You do not have to experience them, right? You learn from others. So your parents probably, when you were smaller, said, don't put your hand on the hot stove eye because it will burn you. And some of you listened to them, and you learned from them, and you learned from their experiences, and you never put your hand on a hot stove eye, and probably still today, you've never put your hand on a hot stove eye. Well, don't do it now. But in a laboratory, you do the same thing, people, right? Use some common sense. You as an employee, when you're first hired, you're not the expert. You getting a degree from a community college or from a four-year school or from a master's program at a university, maybe you're a graduate of Harvard or Yale, you're not the expert. So go into the work environment not with the attitude that you know everything, because you actually don't know anything at all. As far as work safety is concerned, as far as what goes on behind closed doors in that company, you're oblivious to it. You're ignorant to it. So listen to the other people, listen to the other employees, and you'll be much, much better off. So with that said, there's two words here that I want you to kind of take home. And the first one is called a hazard. H-A-Z-A-R-D, and you will learn that my handwriting is not the best. And the other one that we're going to talk about is a risk. A hazard and a risk. Hazards and risk are associated with all jobs. That's the thing here, people. My very first job was working at an ice cream shop. I had to go in and make hot fudge sundaes. I had to go in. I had to serve up French fries and hamburgers. There were hazards and there were risks associated with that job. The hazards and risks were different if I was working in the kitchen versus the hazards and the risk if I was working the front part of the store where the milkshakes and the hot fudge sundaes and everything else was made. But there were hazards. There were risks. Right? If I was in the kitchen, I was working with hot stoves. I was working with open flames. I was working with hot surfaces. I could burn myself. Hot grease, blowing up, catching on fire. If I was in front, well, the hazard and risk were the crazy customers maybe that would come up to the window, right? Who knows what you would have expected. But if I was working at the milkshake machine with the long metal spindle that goes down into the cup that turns around really, really fast to blend the milkshake up, well, hopefully I would not put my fingers or my hand down in there, right? Or if I was cleaning out the soft serve machine, I was taking out all the gears and the parts and the gaskets and everything on the inside to lubricate everything, to put it back. We would have to do that every 2 days. Those were hazards and those were risks. So we've got to define what these terms are. And a hazard, if I start from there, a hazard is the potential source of danger or harm. Well, in a laboratory, it's like any other employer. It's like any other place of business, any other work environment. There are hazards. So you're going to have to become aware of these hazards. You're going to have to figure out what the potential sources of danger or harm are in a lab. The very first day that you walk into one, you should be looking around thinking, what could go wrong? What are the things I should watch out for? What are the things that I should stay away from? Okay, well, what's a risk? Hazards and risk. I'm talking about them kind of like they're separate, right? So what's the definition of a risk? Risk is the probability of suffering harm from being exposed to a hazard. So, for instance, I walk into a laboratory, and that laboratory has a burner, a big flame, right there in the middle of the lab. Somebody's using it to heat something up. That's a hazard. That burner is causing a flame, and that is a hazard. That is a potential source of danger or harm, right? If you don't believe me, put your hand in it. Let me know how it feels. Well, the risk, there's a risk associated with that hazard, and that risk is the probability of suffering harm. So there is a chance, if you're working with the hazard of the flame, there is a chance that a risk is associated. And that risk could be you accidentally getting your hand into the flame and you really didn't mean it. Right? That is a risk. Well, that one is kind of obvious. That one's common sense. Now, give me a break, Tracy, right? I mean, anybody knows good and well not to put their hand in a flame. Well, okay, let's talk about something else that's a little bit more common. I see it over and over in a lab. We have ovens, and these ovens are hot. It's kind of like the oven that you use in your kitchen at home. We turn them on. It's nice and warm on the inside, and what we do, we put our glassware in it. And this oven dries our glassware. So toward the end of the day, we go around to the ovens and we cut them off. But they're still hot on the inside. The ovens are a hazard. The oven is a potential source of danger or harm. And students will go to the oven and they'll open up the door and they won't think about it, and they will put their hands on the inside, their bare hands, and they will grab glassware. Maybe put it back into the lab bench, maybe put it back to where it goes, but they will grab glassware. That's hot. That's the risk. The probability of suffering harm. You've grabbed hot glassware because we have an oven in the laboratory. So that's the definition of a hazard, and that's the definition of a risk. Now here's the thing. There's no way. You cannot eliminate all hazards and risk that are associated in the lab environment. You cannot eliminate every hazard and every risk in any work environment. And you cannot eliminate every hazard or every risk in your own home. Give me a break. There's no way that you can do it. So for all you people that want to work into a laboratory that looks at a lab space and thinks, oh my goodness, we're going to burn the place down. Everything's got to be tidy. Everything has to be prim and proper. We have to eliminate every hazard in this lab for a safe work environment. No, you're not going to get it. It's not going to happen. There's always going to be hazards and risk that are in a lab environment with any employer across the world. You just got to get used to it. So we have to train ourselves to figure out what the hazards are and how to handle those hazards so we don't get hurt, so we don't blow something up, so we don't poison a city that maybe might be nearby a chemical industry or factory. All right, well, this book gives you a way to process these, and it's called RAMP. We're going to talk about RAMP for just a few minutes. Each one of these letters, of course, stand for something else. So the R stands for recognize. We're going to recognize the hazards that are associated with the lab environment. Number 2, A, means to assess the risk. Once you've picked out the hazards, you will have a better idea of what risks are associated with that hazard. What could happen that's bad, right? M is minimize. You're going to minimize the risk. What steps can you take to make sure that those things do not happen? And P means prepare for an emergency. Not pee as in pee your pants. Because trust me, sometimes I feel like peeing my pants when I walk in and I see a fireball in the corner of a room. All of a sudden, what do we need to do? What kind of reaction do we need to take? It can be scary sometimes. But the P stands for prepare. Well, overall, if I have to sum all of these up in some type of way, all this boils down to common sense. Come on, people. Use common sense while you're in the workplace. Use common sense while you're in the laboratory. You might not have a clue about what that chemical's doing or how to dispose of it. But hopefully common sense would tell you, well, if you don't know what it is, don't pour it down the drain. If you don't know what it is, don't get it near an open flame. If you don't know what that hazard is, then maybe you shouldn't be using it. Those are the things that we need to watch out for. Those are the things that we need to do. And that is the definition of a hazard and risk and the RAMP that this textbook loves to use. All right. Something else that I need to kind of touch base with you on. In the laboratory, there are thousands of chemicals. Tons. I'm telling you, tons. There is no way that you're going to know every single chemical in that lab. That's just the fact of life, right? You have to be comfortable with that. You cannot memorize how to handle thousands of chemicals that might be in your stockroom. So, because of that, since there's no way to recognize all the hazards, and there's no way to recognize all the risk, because there's no way to be familiar with every chemical in the lab. And I'll say thousands here. There's thousands of chemicals. This is in a typical workplace. If you take a look at the chemicals that we have just in our lab, there's thousands of those. However, if you look at the chemical industry as a whole, you're talking about millions of chemicals. Millions of them, people. You're not going to know how to handle all of those. You're not going to know how to dispose of all of those. You're not going to know where to store all of those until the first time that you encounter them. However, we try to make your job a little bit easier because in a laboratory, there are some names that we like to use, and we kind of categorize them. So we're going to talk about these categories a little bit later on in the course, but some important classifications would be something like flammable. Right? That means catches on fire, of course. Well, in our laboratory, we have an area that's designated for flammable compounds. We keep all of them together, and we keep them in a separate room away from everything else because we don't want them to catch on fire and go boom! Next ones are toxics. Sometimes poisons gets lumped into this. Well, we keep those separate in a different area of the lab away from common people that might come in and open up a door. Another classification, corrosive. Corrosives, again, are stored separately from everything else. We don't want them to rust containers or rust shelving that they might come in contact with. We don't want them to eat away at things, especially jugs or jars that other chemicals are stored in. But this is a step in the proper direction. We're going to categorize the things that might cause us hazards in the lab. And all of these chemicals have what we call an SDS sheet. You're going to learn way much more about SDS a little bit later on. But an SDS stands for something very special, and it's something that all employees should be aware of, not just lab employees, but anywhere. It stands for a safety data sheet. So what that means is that a safety data sheet has been generated and supposed to be kept in proximity of the chemical of where it's stored. But it's a sheet that I can go to. I don't need the internet. I'll look it up old school in a folder. And I can see that SDS sheet on any chemical that is in the laboratory at any given time. So let's say I pull barium nitrate from the shelf and I begin to use barium nitrate in the laboratory, and now I'm done with it. And I want to know, what do I do with the unused barium nitrate? Does it go down the drain? Does it go in the trash can? Can I put it back into the stock jar? Do I have to put it in a waste disposal container? Do I burn it? Do I react it? What do I do with it? And SDS will tell you that type of information. So I would go to this folder and I would open up the folder and I would look at the SDS in alphabetical order and I would pull up barium nitrate and I would read about it. It will tell me for disposal, for storage. These are the hazards associated with the compound. It tells me all of that information. So SDS stands for Safety Data Sheet. This is more to come. Right? This is going to be later on in the semester. We're going to become more and more familiar with an SDS sheet and what it's all about. So overall, probably one of the most important things for you to do is to realize what type of chemicals that you will expose yourself to in the laboratory. Exposure is going to be the biggest, probably, keyword that we can talk about. And exposure comes from understanding. If you get hired to do a job in a laboratory and you don't know what the crap you're doing, you probably are not going to be able to realize exposure, and you're not going to be able to realize hazards and risk that are associated with your job. But if you're hired to do a job and you go home and you do your homework, and you fully kind of understand what you're doing in a lab and why you're doing it in the lab, then you can go with a new appreciation. And you can already identify these are the things that could go wrong. These are the things that I want to watch out for when I actually go into the lab and do the job that I was hired to do. So don't take it lightly. Now, let's recognize, right? That will help you recognize everything that you expose yourself to, and assessment. The safety data sheets will help you make assessments in the laboratory, right? How do you handle this? What do you do with that? What should you watch out for? And then the next one is minimize. How do we minimize the risk? Well, again, you have to understand the experiment. You have to understand your job, folks. Because if you don't understand what you're doing, you are a hazard in itself, right? How can you fix something that you know nothing about? That's kind of the problem with society nowadays, though, isn't it? Right? Everybody has an opinion, but no one has the experience on that opinion. Everyone feels free to go on social media and type in what they think, and they truly believe that their idea is 100% correct. But you know what? It probably isn't. That's just the way it is now. So you have to accept the fact that you do not know the majority of the things that go on in a lab, and you have to accept the fact that you might not know nothing about something. Therefore, you need to ask questions. You need to bring awareness to yourself, and you need to be responsible and do what you should do when you go home at the end of the day, before you come back to the lab or before you go back to your work environment. You want to make sure that you have a full grasp about what's happening. In order to minimize risk, we often design experiments and procedures with that in mind. So, for instance, we are not going to pick a laboratory protocol for you to follow that makes you work with mercury. At least a lot of it, right? We're going to minimize your risk whenever we can. That way, if we minimize the risk, we minimize the hazards, and you do not get hurt. Or maybe more importantly, you do not get cancer from the reagents that you use in our lab. So, responsible supervisors and responsible educators would go through and they would choose various lab scenarios or lab experiments that they could do that's not going to cause too much of a problem. We're going to play it safe. The problem, though, is that some of our stuff we have to. Some of our stuff we have to expose you to dangerous chemicals because we want to replicate what's going on in industry, and they have no choice, right? If the government tells them that they have to do a test and these are the things that they have to use in the test, there's no way around it, right? They have to do it. And because we want to align ourselves as close as possible to the employer side, as close as possible to what you would see in a normal working laboratory environment, sometimes we've got to expose you some dangerous stuff. And that's just the way it is. So because of that, we would love for you to wear PPE, Personal Protective Equipment. That's what that stands for. Personal protective equipment could be a lab coat, right? A lab coat that you can put on yourself, and if a chemical spills on you, then you've got protection. Personal protective equipment could be gloves. Put on your hands, especially if you're working things that love to absorb through the skin. Well, personal protective equipment could also be goggles. Make sure that you wear your goggles and protect your eyes from any kind of hazard that might happen, whether it's broken glassware, maybe it's reagent splashes, whatever the case is. You've got some PPE on that will help minimize all of the risk that you're taking in the lab when you come through the front door. Finally, Another thing that we can say is go with house rules. House rules, all labs are different, right? Some allow you to put headphones in and work at your own pace, listening to music all day. Some do not. They think that's a hazard. Other times, people can walk in with flip-flops and sandals, and some employers say, absolutely not. You're going to have closed-toed shoes. Cover your toes up. So good house rules are important, and on top of that, good housekeeping. We are not your mama. We are not going to pick up after you. We're not going to do your laundry. We're not going to pick up after your dirty dishes. We're not going to restock everything that you use up through the day. That's just not the way we operate. It's time for you to be responsible. So housekeeping is up to you. Make sure that your lab stays clean. Make sure that your lab drawer stays pretty spotless. Make sure that you're not storing things in it that could go boom or blow up or catch on fire. Make sure that you wash your dirty glassware. Make sure that you put them in the oven to dry and to clean, right? Those are the types of things that we think that you're responsible for, and your employer will as well. So good house rules and good housekeeping practices will minimize those risks. All right, well, what about the P? What about prepare? A lot of people think that they are safe in the lab. However, no one is safe. Always watch over your shoulder, people. This tends to be where most of the accidents happen, right? It's kind of like those stories that you hear, I've been driving for 10 years and I've never had an accident, and then bam, all of a sudden I'm in a car wreck. Or in the actual lab environment itself, you often hear stories of, I worked in this lab for 15 years and we never had an incident like this. That's because people take advantage of it. People get a little lazy with it. So if you think that you're safe, you're not safe. No one is 100% safe in any work environment. I don't care where you work, and especially in a laboratory. So because of that, you always want to prepare for the worst. What are the risks? What are the hazards? And then already have something in plan. If it goes wrong, how do you fix it? Well, in order to do this kind of stuff, you have to do your homework, right? You have to go and fully understand what you're doing and what your job is all about, because if you can't identify the risk, if you can't identify the hazards, then you're not going to be able to prepare for those if they happen. So preparedness goes out the window. So, for instance, if I'm in the lab and let's say a fire breaks out, fire alarm goes off, what do? People run around and they act crazy, right? That's because no one has explained to them what to do in case of a fire. Well, every building and every room should have an evacuation route, right? That is your preparedness. If a fire happens, this is what you do. Bottom line, that's what goes on. That's what we're talking about here, people. If you're in the laboratory and you're working with acids, you could spill an acid bottle in the floor. Hopefully you're not going to use paper towels to pick it up, right? Hopefully you're not going to use a mop and mop it up with water, because it makes it worse. So what do? How do you handle an acid spill? What if it's a base? That could be even worse. Think of Drano getting poured all in the floor. I'm not going to touch it. I hope you don't either. So that is the prepare. R-A-M-P. Recognize it, assess it, minimize it, and prepare it. Prepare for something that can happen. All right, now, the last few minutes here, let's talk about safety. So with safety, being safe is kind of the number one priority, right? Being safe means that you are free from danger, injury, or damage. We all want to be safe. And we rely on you to keep us safe. Because just like out on the road, when you're driving behind the wheel, a lot of times you'll hear people say, well, you've got to watch out for the other driver more than you. Right? As long as you're playing it safe in the lab, then we can kind of pay attention to what we're doing more than what you're trying to do. One of the ways to be safe, don't get caught up in the directions of the lab procedure. Actively think. A lot of times people will read the recipe in the lab. And what they do is that they look at this recipe and they go through and they follow these steps, and they're so concerned with how it's written, they're so concerned with the wording, that they begin to get caught up in all the words and all of the logistics and all of the red tape. And then they don't actively think, and they do what they think it's telling them to do. Then they end up with a nasty fire explosion or a flesh-eating chemical at the end. Don't be that type of person. If it doesn't make sense, it probably doesn't make sense. Get me? So if you read something and it doesn't make sense to you, don't follow it without questioning it. That's why we're there. So you need to come up to us. You need to come up to a coworker. You need to go up to a supervisor. And you need to say, this does not make sense to me. Could you explain it? And then once they explain it, you'll be like, oh, that's what it means. Yes, that's what it means. And there's no harm in asking that either, right? We would rather for you to ask those questions and save a hazard than not asking those questions and putting everyone at danger. The next thing I want to tell you is do not overanalyze. A lot of times people will go through and they will get to the nitty-gritty of every single little bitty step, and it drives them crazy and it drives us crazy. So I'll give you an example. Let's say that you're working with water in the laboratory. And let's say that you look up the SDS sheet for water. You're going to see a statement that says deadly in large amounts. Are you kidding me? No, I'm not. That's how crazy these things can get. Right? Don't overanalyze it. This shows you the extreme of how the SDSs are written. So just because you see something and it says, oh, it's carcinogen, I'm not using that, it causes cancer. Well, it probably does, but it probably causes cancer in very large amounts, or it causes cancer in long-term exposures over a number of different years. And if we're exposing it to you in a very short time frame, in a laboratory environment, especially in an academic setting, you probably don't have anything to worry about. Overanalyze. Think of your gasoline, people. Gasoline is a flammable chemical. It explodes. Well, if you had never worked with gasoline before and you looked up the SDS, you're going to see those statements. Highly flammable, highly explosive. But we drive around with it every day in our car. Right? Don't overanalyze it. Don't overthink it. And don't get your underwear twisted, right? Calm down. It's going to be okay. We're not going to put you into a danger. We're not going to, put your life on the line for coming into lab and working. And your employer is not going to do that either. Okay? What about helping to ensure safety? What can we do to to help ensure that safety is going to be present? Well, you take a look at your facilities. You want to make sure that your lab spaces and your workspaces are clean and clutter-free. Take a look at your equipment. Make sure that if there are dangers associated with them, they're kind of in their own room, away from everything else. Look at your locations of your chemicals and of your equipment. Are the locations of those chemicals, do they make sense? Do you have to walk all the way across the building with an acid bottle in your hand? Or are the acid bottles convenient where you use them the most? Look at person factors. And person factors would be things like attitude, right? You don't want someone in the lab that mopes and grunts around all the time, and then if they spill something, start screaming and running out the door, right? Take a look at your personality. Take a look at your beliefs. Make sure that you're suitable working in a laboratory personality-wise, right? And then take a look at your behavior factors. Behavior factors would be something like safe and risk practices. What that means is that, are you behaving the proper way? Are you actually taking it seriously? If you don't take safety seriously, then probably not. So this is where I'm going to stop this video. I kind of went on for 36 minutes. I'm going to probably go on for another 10, 15 minutes more. But you can stop the video, take a break. Maybe if you've wrote a lot, stretch out your hand, crack your knuckles, and then come back and we'll talk about the second half of this lecture about safety culture.